Hello there, sixth graders. Today we're taking a look at lesson 25, a fraction as a percent, and it is on page 271 of your book. So go ahead and turn. Again, it's 271 of your book. And looking at the first example, it says Sam says 50% of the vehicles are cars. Give three different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, doubled number lines, etc. So we can use anything we want. So this is actually a really easy example that it's giving us. Um, I know that in your mind, you can look at that and tell me if half of them are cars, but we're going to show it mathematically. Okay, so that's the difference. All right, so first thing, we can create ratios. So if I started looking looking at it with a ratio, I could say there are 3 cars to 2 trucks. Okay, 3 cars to 2 trucks. I could also do, well, there are 3 cars out of 5 vehicles. Which one of those is going to be more helpful to us? Yeah, probably this one, okay, because we're looking at cars. If we wanted to do the ratio of trucks, it would be 2 trucks out of the 5 vehicles. Now, knowing what 50% means, what does it mean? Means half, right? So if we have half of something, these two things would be identical because half cars and half trucks means that whatever numbers we had, they should be the same if they're each half. So right there, we know that they're not. We could show it as a grid if we did a 10 by 10 grid. Okay, and we need to cut it into fifths, which are 4 lines, beautiful lines, right? And out of these 5 vehicles, 3 of them are cars. And if 3 of them are cars, I can see by looking at this is more than half. So that's another way. What if we did, let's just do kind of a tape diagram. And we have our 5 vehicles. And again, here, 3 of them are cars, and only 2 are trucks. Well, we know that half is right in here. So that shows us it also. So we've shown 3 different ways. Looking down here, how is the fraction of cars related to the percent? Well, our fraction of cars, we already said, was 3 to 5. So 3 out of 5. And what did we say that percents always are out of? Good, 100. Percents are always out of 100. How do I get from 5 to 100? Times 20. Think of, we have 20 nickels if you go the other way. So 3 times 20 is 60. Good. And so as we have 60, we know that 60%, because it's out of 100. So we know that those two things are equivalent. Equal. Let's use a model to prove that the fraction and percent are equal. Well, let's use our double number line. And if we do that, we know we're going to put, let's do our percent on the top, and let's do our cars on the bottom. Actually, I should have said vehicles. Vehicle. And let's do percents and cars or vehicles. So we have 1 vehicle, 2 vehicles, 3, 4, 5, and all of them together we know are 100%. So we have to figure out, what are we counting by in order to get 5 lines that are up to 100? What would each of these be worth? Well, what's 100 divided by 5? 20, right? So this is 20%, 40%, 60, 80, and 100. And then I can see we're proving that the fraction and the percent, here's our percent, here's our fraction. Are they the same? Absolutely. We're looking right here. So 3 out of 5 is the same thing as 60%. And the last one that we're looking at says, what other fractions or decimals also represent 60%? So we knew 3/5 did. We already had that. Well, what if I double both of those? What does the 3 become? Right, 6. And the denominator? 10. What if I instead multiplied this by 3? 3 times 3 and 5 times 3. Well, again, what if I do it by 4? 3 times 4 is? And 5 times 4. And you could go on forever. All of those, okay, all of those are the same thing as 60 over 100, 60%. We could also have written that 60 tenths hundredths, so 0.60. And again, is this 0 necessary? Nope. We could write it as 0.6. So all of those are the exact same thing. All right, go ahead and turn the page. 272, top of the page. On the top of the page, it says, a survey was taken that asked participants whether or not they were happy with their jobs. An overall score was given. 300 of the participants were unhappy. 700 were happy. Give a part to whole fraction for comparing happy participants to the whole. And then we're going to do the same thing for the unhappy. And then we're going to say, hey, what percent were happy and what percent were unhappy? So let's look at happy. How many were happy? Okay, let's look up here, right here. 700 were happy, 300 were unhappy, but we need part to whole. So happy, there were 700 out of how many though? What do we have to do to find out how many there are total? Good, we're going to add 700 plus 300. So that's our 1,000. And then unhappy, we had 300 that were unhappy out of the same thing. So the whole was 1,000. Now I need to know how to change this to a percent. Well, what is a percent always out of? 100, right? Well, this is 1,000. So how am I going to get to 100 instead of 1,000? I need to get rid of this 1 0, right? Well, since I can cross off 1 0 here and here, that's the same thing as saying 70 over 100, which is what percent? 70%. So over here, what can I do also? I can do the same thing, right? I can take off a 0 off of each one. Now my fraction has 100 on the bottom, which is what I need for my percent. So now it looks like that, 30 over 100, which equals 30%. Then it says, let's create a model. Let's do our same thing, our double number line. And we're going to put our percent on the top again. And our participants or people, I'll just write people, on the bottom. And we know that our people, we have 1,000 total. So a good number to probably count by, because both of them are in hundreds. So I know I'm going to count by hundreds, which means I'm going to have 10 spots here, which is 9 cuts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is 100. And you can go ahead and label these quickly. All right. And if this is 100%, each one of these is how many percent? 10%. You're right. 10, 20, and I'm just going to finish writing it without my percent signs. And what am I showing? I'm justifying that 30% is the same thing as 300 out of 1,000. Well, here's my 300 out of 1,000. And if I circle that, ooh, that was not good. Let's undo that. All right, there's 300, which is 30%. And then I can also see that 700 is 70%. Not too shabby. All right, let's go on to exercise 1. Talks about Renita. And it says Renita claims that a score of 80% means that she answered 4 out of the 5 questions of the problems correctly. She drew this following picture. So take a look at the picture, and we're going to decide, is she correct? Why or why not? Is she correct? Well, if we look at it, hopefully you can see that here is 1, 2, 3, 4, 5 rows. Remember, rows go across and columns go up and down. Okay, so that's columns. So we're not worried about the columns right now. We're going to worry about these rows. Are 4 out of the 5 of the rows shaded? Right, they are. So we need to know, is that 80%? Well, out of all of these boxes, there are 100 boxes there. And we have right here 20 of them not. So yes, she is correct. Now, why is she correct? There are 20 or 80 boxes are colored, shaded. And that is, that is 4 of the 5 rows. So yes, it is. Now, how could you change this picture to make it way easier for us? What could we do different? Well, the things that I kind of thought of, if she would have numbered these as her rows, 1, 2, 3, 4, and 5, I could easily see that 4 out of the 5 were done. She could have also maybe counted. This row is 20%. Here's 40%. Here's 60, 80, and 100. And she shaded it. That would work. She could have, if she really wanted to, she could have did a double number line. She could have drawn lots of different things. Okay, so those are some things that she could do if she would like to. Let's look at exercise 2. It says use the diagram to answer the following questions. Okay, so it says 80% is what fraction of the whole? Well, go over to 80%. Can we find 80% on this? Yeah, right here. So the whole is 5. So what fraction is that whole? Right, 4 out of 5. 80% is the 4, and it's 4 out of 5. What is 1/5? Or sorry, 1/5 is what percent of the whole? Well, all we have to do is go look at where our 1 is, because we have 1 out of 5, and it is 20%. Way easy, right? The last one says 50% is what fraction? Well, 50% is not here. Do you see that? It's not really listed, but I know that 50 is between 40 and 60. So the line that I'm drawing right here in the middle would be 50%. Well, and it's smack dab in the middle between 40 and 60. So what's between 2 and 3? You could say maybe like between $2 and $3. And we would know that that's $2.50 or 2.5. So what fraction? Well, it would be 2.5 out of 5. 2.5 out of 5. All right, let's take a look. Exercise 3. It says Maria completed 3/4 of her workday. Create a model that represents what percent of the workday she has worked. So let's go ahead. I'm going to just draw kind of like a tape diagram. Beautiful, right? And it says here is 3/4 of her workday. Well, her whole workday would be 100%, right? And here would be our 0. Well, she didn't work 100%, but she did work 3 out of the 4. So we need to cut this tape diagram into 4 pieces. If I cut it in half, I made 2 pieces, and then cut each of those halves in half again. So here would be our 1, 2, 3, and 4. So here is the part of the day, and here is our percent. And we know that if we cut this into 4 pieces, we have to cut 100 into 4 pieces. Well, this is smack dab in the middle, so I know that's 50%. So what is half of 50? 25. And so here is 75. So when we take a look at what Maria does, I can see that 3 out of 4 is 75% of her day. So 75% worked. And then it says, what percent of her workday does she have left? Well, if she worked 75%, how can I find out how much she has left? I can either know that this right here is 75% plus something equals my 100 and find out what that is. Or I can actually subtract. Well, here's the whole day. Take away what she already did. I would have to borrow. And 25% is left. How does your model prove that your answer is correct? Well, we showed that there was 1 out of 4. Ooh, that was not nice. 1 out of 4 left of her day, and 1/4 of $1 is 25 cents. 1/4 of 100% is 25%. Go ahead, and we're going to head on back to the classroom.